Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the blind Leetcode 75 problem list. Today I will be doing problem 121, which is called Best Time to Buy and Sell Stock. So, the problem statement says, you are given an array prices where prices sub I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So we have this example right here, which is prices. So 715364, and the output is 5 because we buy on this day right here, and then we sell on this day right here. So 6 minus 1 is equal to 5. Input, we have prices here. It says no, that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. So we can't buy here and then sell here, and the output will be 6, but that's not allowed. And then we have this prices here, and the output is 0 because the price just keeps decreasing. Okay, so yeah, this is a fairly simple problem as well. So if you want to take some time to solve it by yourself, now will be the right time to start. And just pause the video, and whenever you're done, then just go and check by yourself the solution in this video. So let's get to work on it. So the main idea here, right, is that we want to sell a stock after we bought it at a lower price. Now, how do we determine what the biggest gap between a selling day and a buying day is? Well, for starters, right, I can tell you that we can solve this problem in just one pass, meaning that we can visit each element in the array just once as we go. No need to traverse all these, store some information, blah, blah, blah. No, we can just do it as we go. And how do we do this? Well, one thing that we have to keep in mind, right, is that we make profit when we bought at a low day and we sell at a price that's higher than the previous day, right? So, we can think of it as, okay, imagine that we've bought it a certain day, right? If we encounter a day that has a higher price than we bought, then we've definitely made some profit. But we want to maximize that, right? So how do we do this? So imagine, for example, right, that right now I bought a stock at, out of all the arrays that all the entries in the array that I've encountered, right? So far, the best buying price that I could find is 6, okay? Imagine that. I don't know if you guys hear that in the background. There's like an airplane flying over my area. So if there's a little bit of noise, I apologize for that. But anyway, suppose that right now, right, we have found that the best price to purchase a stock as we go through the array is a 6. What happens, right, if we encounter, let's say, an entry that's 2? Well, yeah, that's getting pretty loud, sorry. So what happens if we encounter a day in which we can buy the stock at 2? Well, logically, right, we will want to buy the stock at this point at 2, right? Because no matter what price we encounter afterwards, right, if we'd say, let's say 8, 2 will always be a better price to pay than 6 because it's cheaper, right? So whenever we encounter a number, so what we're going to do is we're going to store, right, what the current minimum that we've encountered is. Because for us it's always best that whenever we encounter a cheap price, then we set that as our purchasing date, right? We just say 2 is always better than 6 because the following gap will always be bigger than the previous one, right? But at the same time, we want to keep track of what the biggest gap is, because imagine that, for example, we have something like this, right? This is a very extreme example, but I think it sets up what I'm trying to say fairly well. So suppose that we have this array, right? Then obviously we can see that the biggest gap by far is just buying here and selling here, right? Because there's literally no question about it. So what we want to do is whenever we encounter a number that's smaller than the current minimum that we found, right, we update as the buy price. We update that as the buy price. But at the same time, if we don't encounter a number that's smaller than the current minimum we found, then we have to find the minimum difference, like the difference between the current number and the minimum that we've encountered so far. And if that difference between the two numbers is the biggest difference that we have encountered so far, then we will store that as the value that we want to return. So in this case, right, we start with a minimum at 6, and then we find that this number is obviously bigger than 6, right? So we find the difference between these two numbers, and then we just store it, right? So that'll be that. Our current minimum is still 6, and this is the number that we want to return. Then we find the 2, right? And then 2 is our current minimum. And then we find a 4. 4 is bigger than the 2, and the difference between 4 and a 2 is 2. So that difference, we have to compare it to the biggest difference we've found so far. And obviously, that's smaller than this number right here. So we just keep going until we find a bigger difference, or the array is over, which will be after the 8. And that will be the end of the problem. So let's get to code it now. Okay, so one thing is that we want to return a value, and like it said in the problem, it's if you cannot achieve any profit, then return 0. So our default value here will be 0. Now the biggest element that we're going to encounter will be, well, the first element will be the minimum. So the current minimum will be the first element in the array. Sorry. There you go. And then we're going to traverse the rest of them. So for I in range 1 to the length of prices, we can say if price is sub I. So if the current element that we encounter is smaller than the current minimum, then obviously the current minimum will now be the current prices, which is the example from before with the 2 and the 6. The other case that we're interested on is if the gap is bigger. So if the difference between prices sub I and current.min is bigger. So else if prices sub I minus current min is greater than the number that we want to return, then we simply set to return equal to that gap. And that'll be the end of the problem. This is the most efficient solution. I'm gonna run it a couple of times because my internet is pretty slow today, but I've been testing the code before, and eventually it got to like top 98%, which is this submission right here. So yeah, you can see now it's like 6%. But yeah, I'll probably just make a cut in the video until you guys see this runtime. Okay, there you go. That's good enough. But yeah, so this is the optimal solution for the problem. And let's see what the runtime is and the space-time complexity for this problem. So the runtime for this problem is big O of n, because we traverse every single element in the array just once. And the space complexity is big O of 1, because we're simply returning we're simply storing a couple of variables. It's not related in any way to the array size, so it's just big O of 1. And that's it. So yeah, I hope you enjoyed the video, and as usual, make sure to drop a like, subscribe, and thank you so much for watching this video, and see you in the next one. Bye-bye.